All right, in this objective, we are talking about understanding the unit circle and how to use it and find values of sine, cosine, and tangent in the reciprocal functions. All right, let's just see if we remember about the actual basic three trig ratios, sine, cosine, and tangent of an angle. So remember that little thing to help us out? It was called SOHCAHTOA. SOHCAHTOA. Hopefully you remember that. So sine was opposite side divided by hypotenuse side, OPP over HYP. I just abbreviated. Cosine was the adjacent side divided by hypotenuse side. And then tangent was O over A. That was opposite over adjacent. So if I had a right triangle, I was able to find any of the missing sides there using sine, cosine, or tangent. So now we have reciprocal functions of these three. Reciprocals, meaning if I just going to flip the fraction around. So the reciprocal name for sine is called cosecant, which is abbreviated CSC. So the cosine of an angle would be hypotenuse divided by opposite. The reciprocal name for cosine is secant, which is abbreviated SEC. And again, we flip it around, hypotenuse over adjacent. And then the reciprocal name for tangent is cotangent, and we abbreviate as COT of an angle. And again, we flip it, adjacent over opposite. So these are for the right triangles. Now, how are we going to be using this concept on a unit circle? Well, what is a unit circle? It's a circle whose radius is 1 and the center is the origin. So here is a circle, and it's got a radius of 1 on the unit circle here. I want to explain how they're getting what each degree is the value on the unit circle. So here we have a right triangle being made. Here's the angle theta, whatever it is. We have our xi, which is on the x-axis here, the initial. We have our radius of 1, that's the hypotenuse there. And then you see that bluish line going down, straight down. That's actually the distance of that point on the y-axis. So if I ask you to find the cosine of theta here, well, we know cosine is adjacent over opposite over hypotenuse. So the adjacent side is x, the hypotenuse side is 1. That's how they're getting cosine to be x over 1 or x. All right, let's erase this again. If I actually find sine of an angle in here, and sine is opposite over hypotenuse, so the opposite side is y. The hypotenuse is 1. Y over 1, which is y. So on the unit circle, this is the most important thing here, is that cosine is always the x coordinate, the x. Sine is the y coordinate. Tangent is the reciprocal of y over x. So if you think about it, y over x, that one is opposite over adjacent, so y divided by x. And then we have the reciprocal function names, right? Secant, so it's 1 over x. Cosecant, 1 over y. And cotangent, x over y. So make sure you have those 6 things written down there. Now, this and the one that's filled in, I gave this to you guys. This is a unit circle. So I want to talk about how they're getting certain things on here. So we did this in class together, how we got the degrees. We converted everything to radians around, and then we figured out what is the cosine and sine for each of these points. So I'm just going to go and advance on to this next slide, which has them already filled in here. You should have your own. My suggestion is to print it out. You definitely need this for your test. So they're going from 30 to 45 to 60 to 90, and it keeps going around, so on and so forth there. All right, if I wanted to find and evaluate, it says find the exact value, no decimal answers of the following. So the exact value means I need to use the unit circle. So cosine 60. So I'm going to go to 60 degrees right here. Which one is cosine? We know cosine is the x-coordinate, so we know this answer is a half. I'm going to add on to it sine of 30. Where is 30 degrees is here. Sine is the y part of the coordinate, so that's another half, minus tangent 45. All right, where is 45 degrees? Right here. Tangent 45, here it's already giving us that they get it to be 1. How did they get it to be 1? Well, they did y, root 2 over 2, divided by root 2 over 2 itself gives us the value of 1. So now I'm going to evaluate this. A half plus a half is 1, and 1 minus 1 is 0. All right, let me erase this. Let's take a look at now number 2. All right, we need to find secant of 60 degrees. Now, secant is the reciprocal of cosine, right? So let's go to 60 degrees, which is here. And we're going to look at cosine first. And cosine is this x part. But what do I need to do with a half? It's the reciprocal. So I need to do the reciprocal of 1/2, which is 2 over 1, or just 2. Next one, 45 degrees, cotangent. Well, I need to go and get tangent and do the reciprocal of it, right? So let's go to 45 degrees. So we know tangent of 45 degrees is 1. What is the reciprocal of 1? It's 1. All right, last piece, cosecant is the reciprocal of sine. So let's go ahead and go to 30 degrees. Here it is. Let's go to sine, which is the y, a half. So sine of 30 is a half, but we want to know the reciprocal of that one, reciprocal. So the reciprocal of a half, again, is 2 over 1. And here we go ahead and add this up. 2 plus 1 plus 2. That gives us an answer of 5. All right, last thing. It says find all 6 trig functions if the point on the unit circle is negative root 5 over 3, comma, negative 2/3. Now, this is not straight on the unit circle from here, right? It's not. It's somewhere in here, but it's not the ones that we know that go by 30, 45, 60, and so on. So we're going to do the same thing that we know to do if we have a point on the unit circle. We can get all of them because we know that the x is my what? And what's my y? My x is my cosine. So I know the cosine of this angle is negative root 5 over 3. I know the sine, that's the y, is negative 2/3. I could get the reciprocals of these two, right? So the reciprocal of cosine is secant by flipping this around. So I'm going to flip this around. Now, this is not allowed in the denominator, root 5, so hopefully you remember that you have to multiply it by root 5 over 5. Multiply this across, so I get negative 3 root 5 divided by, these two multiplied on the bottom gives me 5. So the secant of this angle is that answer. What is the reciprocal for sine? That's cosecant. So I'm going to do the reciprocal of negative 2/3, which is negative 3/2. I still need tangent. So tangent is taking my y and dividing it by x, right? So my y is negative 2/3. I'm going to write it this way going across because I need to do copy dot flip, right? When I divide fractions, so I'm going to copy this, change it to multiplication, and I'm flipping this around. Hopefully you notice the 3's cancel out, right? I'm going to multiply this, and I get it to be negative 2 over negative square root of 5. Well, can't have root 5 in the bottom, and we know that 2 negatives become a positive. So let's go ahead and rationalize and multiply this by root 5 over root 5. So I get 2 root 5 on the top, and what's root 5 times itself? It is 5. So the tangent is 2 square root 5 over 5. All right, last one is doing the reciprocal of cotangent. Reciprocal of tangent, which is cotangent. So let's do the reciprocal of these two. So that means I'm going to be doing x over y, right? X over y. So my x was negative root 5 over 3 divided by negative 2/3. Copy, dot, flip this around. Looks like these 3's cancel. 2 negatives on the top become a positive, so it's square root of 5 over 2. That's the cotangent value for this angle.